So I'd like to go through a couple of questions to do with using quadratic graphs in a sort of a practical scenario. So many exam questions will be given with a context, a real life context, and they'll describe the situation. They'll usually give you the function to use plus the domain. So I want to have a look at a few examples. So here we have an example where they have given us a function and 4 minus 3x minus x squared, and they've asked us to fill in a table, and they've made it clear that the domain is from minus 5 up to 2, and you can see that in terms of the value of x. The domain refers to the values of x, the inputs that you put into the function, and you're asked to complete the table. And what it will then we'll then use these values that we want to work them out to be able to apply, in this particular case, it's modeling the temperature in centigrade between certain times, and we'll talk about how you work out the times and compare it in a moment. But first of all, let's just fill in the table. Now I've shown every single calculation there, and by substituting each of the x values into the function. Now, I'm also a big fan of using the calculator. You have the calculator in the exam, and you can use the table mode on the calculator. So to get to that, you click on mode or menu, and click on 3 to get the table option that you see there. Okay, and it will say f of x. So then you type in the function. So in this case, it is 4 minus 3 lots of x, and to get the x, that's the red x you see there above the bracket. So to access that, you have to use the alpha button. So alpha bracket gets you the x. Okay, and then we carry on with the remainder of the function. So it's minus, same again, alpha bracket gets the x, and then you press squared. So that's the function there, 4 minus 3x minus x squared. Once you've done that, you press equals. On the newer calculators, they also give the option of g of x, but we're not interested in the second function. So if you get that up, you just press equals again to go on to the next step. The next step will ask you for the start and end values, and also the step, whether it be done as a table here or whether it just asks you one point at a time. So here we're going to type in minus 5 as my start value, because that's the start value that we see here. Oops, sorry. We then have for the next value, we've got the end value of 2. And lastly, the step. Now, the step is going to be 1 because we're going up 1 each time. Okay, the step is 1. That's usually the case. Occasionally, you might get a different step, but it's very rare that it'll do that to you. So press equals again, and we now have a set of data there. So we've got the values of minus 6. That's the same as the one that's the first one there, so we know that's correct. Next one down is 0. And then we've got 4 and 6. Moving down, we've then got 6, another 4, another 0. And then unsurprisingly for the last one, we've got minus 6. Now, I'm quite happy with that. I can see there's actually a symmetry there. So I know for certain that I've got those right. Now, if you don't have a nice symmetry to the numbers, doesn't mean you've got the numbers wrong, but certainly if I do have a symmetry, I know I'm fairly confident that I have no issues with what I've done so far. But the point here is the calculator's there. As long as I've typed the function in, the calculator's going to give me the right numbers. So when I'm going to do this graph and plot those points, I'm going to need values for x from minus 5 up to 2, and the y-axis needs to be values from minus 6 to positive 6. So you always need to make sure that you draw your axes appropriately with the right length to be able to put in an appropriate scale, making sure that you're along any particular axis, the scale is spaced out correctly. So for the space that I've got here, all I've been able to do is I can have 2 squares per unit along the x, and I've got 1 square per unit along the y. I'm limited in this space here, but I'd like it to be taller and would love to space it out a bit more, but I can't. So plotting the points, And so what points we're talking about here is we're talking about -5, -6, then -4, 0, -3, 4, and so forth. So I've plotted the points, and then I can join them up with a nice smooth curve. They're never going to be perfect, but as long as you can do the best you can. If you obviously have pencil, you can sort of rub it out and improve it with a sort of sketching process. I'm limited with this digital pen to be able to do something that's ideal. Anyway, so now we're actually going to use this to try and sort of apply it to a scenario. So the key thing we need to appreciate is, what do these x values mean? So x equals -5 is referring to 6 o'clock in the morning. So in terms of my time, and then 2 o'clock, x equals 2 is 8 o'clock. So to some extent, the first thing I need to work out is what's their scale. So obviously 8 o'clock is 2000 hours. Okay, so, and 6 o'clock is 600 hours. So how have we gone to go 1, 2, 3, 4, 5, 6, 7 steps beyond the first one? And we're going 14 hours. So each step here, each value of x, each unit, is worth 2 hours. So let's just test this out. 8 o'clock, 10 o'clock, midday, 2 o'clock, which is obviously, it's 1400 hours, 4 o'clock, which is 1600 hours, 6 o'clock, which is 1800 hours, and 8 o'clock in the evening, which is 2000 hours. So that works. Okay, that gives us a set of time. And in terms of your scale along here, okay, whilst I wouldn't recommend you write all the way over your graph, okay, if you can at least appreciate that this point here, 6 o'clock, 8 o'clock, 10 o'clock, 12 o'clock, 2 o'clock, 4 o'clock, 6 o'clock, 8 o'clock, okay? Very helpfully, I've got here 2 squares. So each square along the x-axis is actually an hour. So 7 o'clock, for example, is halfway between 6 o'clock and 7 o'clock, 8 o'clock, which is here. So that this is 7 o'clock. So 7 o'clock, supposedly, it's approximately -3 degrees centigrade, and so forth. Anyway, let's have a look at the question. So use the graph to estimate the temperature at 11 o'clock. So 11 o'clock is between 10 and 12, between -3 and -2, okay, between -3 and -2. So here, this here is 11 o'clock, okay? So 11 o'clock is halfway between -3 and -2. So 11 o'clock, if I take some plotting up and across, it's a little bit more than 5 degrees, okay? So I might say it's 5.5 or 5.3 degrees centigrade, okay? As long as you've sufficiently read off your sufficiently well-drawn graph and provide an answer, whether it's the exact same as the answer in the back of the book or answer the mark scheme in the exam, doesn't really matter. So the time when the temperature was highest, so the highest was the peak in between the 2, 6 values. So here, okay, -1.5. Well, again, if I go back to my graph, I can see halfway in between -2 and -1 is 1 o'clock. Okay, so I'm reading down to this point here. That's 1 o'clock. So 1 o'clock. And the times when the temperature was 3 degrees. So 3 degrees in temperature is here. So I'm talking about that value there and that point there. So I can read off a value. It's going to be not an exact science, this one. So let's look at this. Okay, so it's almost -3. Okay, it's almost 10 o'clock. Okay, it's between 9 and 10 o'clock. It's approximately halfway. So I'm prepared to suggest the temperatures for the times for a temperature of 3 degrees is going to be approximately 9:30. Okay, so I'll do that. I'll say it to you again. I've taken 3 as my temperature. I've gone across the graph. I've read down to here. It's between -4 and -3. It's between 8 and 10 o'clock. So halfway, i.e. -3.5 is 9 o'clock, and it's halfway in between 9 o'clock and 10 o'clock. Okay, so that's why I've said 9:30. And then the other one over here, okay, again, I'm going to have a similar methodology. So it's a little bit between 0 and 1. So between 0 and 1 is between 4 and 6 in the afternoon. There's 5 o'clock, okay, at a half. So it's a bit before 5 o'clock. So it's approximately 4:30 in the afternoon. So 4:30 p.m. and 9:30 a.m. will be the times when the temperature was 3 degrees. By the way, very quickly, you'll notice the plural. They'll always ask a grammatically correct answer. So here there were 2 times, okay, and their hint is in the question that there's more than one, as opposed to the previous example, which had a specific time. The number of hours the temperature was at or above freezing point. Well, it was at or above freezing point between 8 o'clock and 6 o'clock. Okay, you can see that here. So 6 o'clock and 8 o'clock. So it's a case of just working out the time difference between 6 o'clock in the evening and 8 o'clock in the morning. So 1800 hours minus 8 is 10 hours. So it was 10 hours, it was above 0 degrees C. Now the mathematics wasn't specifically difficult, okay? Getting a bunch of values out of a function, plotting the points, drawing a graph should be reasonably straightforward. The complexity was in a less tangible way, was the issues of that time and trying to work out your scale and making sure you don't make any mistakes. It's easy to make mistakes, but this is the skill that you need to develop in this exercise that you're going to be doing. It's sort of the practical conversion from the mathematics to the practical scenario. So what I'm going to do is I'm just going to go through another question. Okay, it's actually one of the questions from the exercise, question 4. Okay, and certainly question 5 would be similar, and I'd recommend you certainly have a go at question 5 yourself. I'm going to go through this a little bit more quickly because I've explained the basic processes. So now I'm just going to get on with the question. So we have a function of 8x minus x squared. We're given a domain from 0 to 8, so we can work out the values. We can use our calculator to help us. So we've got the function in there, and we've got the right domain values from 0 up to 8 with steps of 1. And so we can fill in our values. You can see here we've got our values of 0 and 7 and 12 and 15 and 16 and 15 and 12 and 7. And almost certainly the last one is going to be 0. Yeah. I'm wanting a scale from 0 to 8 along the x-axis and from 0 up to 16 on the y-axis. And I can plot the points using pencil and smooth curve. Now the purpose of this function was to describe the area. Okay, so the y-axis, okay, is the area. Okay, the area A is equal to and x is the length of one side. So we're talking about here, we've got a situation where we've got a rectangle where one side is referred to as being x, and since it's 16 in total, then you've got 8 representing the 2 sides. That's why we've got another side which is 8 minus x, and that's why the area is the multiplication of those two things. Hence the reason why they've given you 8x minus x squared. Okay, so the height represents the area, and you can see there's a maximum area we can get, which seems to be 16. Okay, and that's actually the answer to part 2. We're told, we're asked maximum possible area and the value for x for when this occurs. Well, this literally occurs at this point here. The A is 16, and that occurs when the length of one side is equal to 4. Okay, so basically you're going to get yourself a square. The area of the enclosure when x is 2.5, so there's 2, there's 3, so 2.5 is along this point here. So what we're going to get is we're going to get a value of, well, it's about 14. It may be just below 14. It depends on how you draw your graph. Two people might have slightly different graphs, okay? But the area is going to be approximately 14 or maybe 13.8, you could probably put as well. Now this is meters, so you should always make sure you put your units in there just to make sure that you don't end up losing marks. So meters squared. What two values of x will give you an area of 12 meters squared? So for 12, we can find 12, the area of 12, and we can read off the graph. Again, that should be very simple because there are actually points on it that we've actually worked out already. You'll see that we have this solution and this solution that meet the requirements of part 3. Okay, so the values of x are going to be 2 and 6. So I hope you've have an understanding of how to interpret the graph in a practical context. It's not just x's and y's or x and f and x. It might well be that there's, there may be t instead of x, because it might be referring to time, and other letters such as A and V and others might be used as well. Have a go at exercise 17.4 anyway.